Okay, Panagdayat Tanan, good afternoon. So this is the video that I have promised to post to you. This is a discussion slash demonstration of selection sort algorithm, which is one of our topics from our previous sessions. So I will explain to you further the meaning of the code, the, this particular code, which is basically the implementation of the concept of selection sort. And basically selection sort compared to bubble sort, which constantly and regularly compare and swap. With selection sort, it will select for the minimum number. It will still compare the numbers. It will still swap the numbers. But compared to bubble sort, selection sort will go through all the data items and will compare for a particular minimum number. And so until we find a minimum number along the way, we will consider it and we will swap it to the first index. And so we are kind of assured that from that particular round off, from that particular um, comparison and swapping, we are sure that the leftmost corner or the first index already contains the smallest data item. Comparing it to bubble sort, it will go through a series, a couple of comparison or swapping off along the way until it becomes sorted. So theoretically, selection sort is quite faster than bubble sort. So as to the discussion from our previous lesson, this is our block of code and it contains another two blocks of code, the outer loop and our inner loop. And then we declare three variables. We name it out, in, and mean. And these variables are essential. They will be used later as we go along with the source code. So from this particular outer loop, we say that we use the variable out. It should begin from zero. And then we also said, for as long as out, the variable out is less than the number of elements minus one, then we will run this code. Now, I have already explained to you the meaning of this particular part of the code. We need to deduct one because if we count off the following sample data items, and by the way, these data items are the exact data items that were given to you from the original code. And as you can see, I have just cut it into half. I just took the first five numbers so that our demonstration will not be as lengthy as compared to dealing with all the data items. But essentially, the concept and the application will still be the same, right? So if we count this off, although the size of the data items is five, one, two, three, four, five. Please note that arrays do not begin counting off data items from one compared to human beings because it begins to count data items from zero. And that means this particular data item is placed in index zero, index one, index two, three, and four. So essentially, we do not use the value of five, which pertains to the size. Rather, we use the value of index. And so that's why comparing it to its size, which is five, we need to deduct one so that uh, we arrive to this particular format or to this particular setup. And in this case, again, we need to be able to meet the requirements of indexes. So your index will always begin from zero. And so since we have five items here, we will stop right at number four. And so that explains why this formula begins from, or this formula deducts one to it, right? So essentially, this means four. Okay. And then, of course, the initial value of the variable out is zero. And if we compare this one, this is true. And because it's true, we will run this code. So meaning out is less than 4. Yep, it is. It's true. And so we need to run these statements or series of codes. Now, our code here states that out is initialized to 0, and our a variable called min is also initialized from the value of out, which is 0. So if we label it here, so variable out has 0 value and minimum as well. Since it is based from the variable out, we will put 0 as well. Now, the variable mean is the variable that holds the minimum number. So in this case, we are assuming, the code is assuming, selection sort algorithm is assuming that this particular value is, as of now, our minimum number. And then we will go through the following, the other or the remaining data items, to find for another number that is indeed lesser than this one. If we are able to find a number that is lesser than 77, then that means that particular found number is going to be the new minimum number, right? And then as you can see, there are at least three data items that are smaller than 77. Particularly, these are 44, 55, and 22. So later, we will go along with these data items based on the given code. If we go back to the code, we say that the minimum is reference to the value of out. Again, that's 0. And that means that our minimum for now is 77. It's not really 0 as in the digit 0, but 0 here pertains to the index. And index 0 has the value of 77. Okay. Now, because this condition is true, we will also run the following inner loop. With inner loop, it says it uses the variable in, and that represents the inner loop, right? So in here, based on its algorithm, states that you begin from out, which is 0 plus 1, meaning we will begin from index 1, right? Because if you will count this off, it simply means in is equals to out, and out is 0 and plus 1. That means our variable in here has the value of 1, right? And 1 is the index, and index 1 contains this particular value, or 99, right? And of course, this will essentially become 1 if we simplify it, right? So this is how your memory looks at it, right? So I'm just changing it for the benefit of the discussion. And so later along the way, you will understand why in this case we did not deduct 1. So along the way, you will understand why. Right. So this means that in is for as long as the value of in is less than the value of number of elements, which is 5, because this time we did not deduct 1, then run this code. Again, for as long as the value of in is less than the number of elements, which in this case is 5, because we did not deduct 1 compared to this particular part of the code a while ago, then we will run this one for as long as this is true, right? If I may just arrange this, okay. So since 1 is less than 5, then we will run this one, right? So if we interpret this code, for as long as this is true, then we run this again, right? Again, for as long as this is true, we run this again. So when you read loops and if statements, we will always evaluate its Boolean result. If it's true, then you run the whatever is inside the block. Again, when reading for loop or if statement and other repetition control structure and condition control structure, for as long as the result of the Boolean expression is true, that is the only time we will run whatever is inside the block or whatever the code is. If it is false, then we terminate it, meaning we do not run the code and we go out from its block, right? So if we interpret this one, array, because assuming that the name of our array is A, if we simplify this one, it simply means the index in of array A is it less than the index mean of array A. Now, if we simplify that one, it simply says since this particular index refers to in, which is 1, and if we go back to our sample data item, it pertains to 99, right? So if we simplify it, it simply says if 99 is less than, then again we check it, A, array A with index min. If we double check again our table, our min is 0, and that means 77, right? So that simply means if we simplify this, and this is how your memory looks at it, okay, okay. If 99 is less than 77, then run this one. However, if you check it, 99 is less than 77 is obviously not true, right? 99 is not less than 77. In this case, the result of the Boolean expression is false, and that means we will not run this one. Also, that means we will terminate and go out from this particular block, right? And since we are inside, we are still inside this inner loop, this means that we will increment this one because the result of the comparison, the result of the Boolean expression a while ago is false. And then that means we will go out from our if statement and then we will return the control back to our inner loop. Now, your inner loop states we will increment into 1, right? So in other words, your in will now become 2. And if we update our table, this will also become 2, right? So we go back to the question, is 2 less than number of elements or 5? Yup, it's true. And so we will run this again, right? So the figure will now change because your in variable is now changed to 2. And that means we will need to get the index of in, which is now 2 from our array. And if you look at our data items, index 2 is 44, right? So that means if we simplify this one, this simply means if 44 is less than uh, index min of array A, and please recall that the variable min still has the number or the index 0, and so it remains 77, right? So it means if 44 is less than 77, then run this one. In this case, this is now true. Boolean expression, 44 is less than 77 is now true, right? And that means we will run the following statement. And also, because that is true, it simply means that we have a new minimum number, right? In other words, because we found 44 as smaller than 77, then we realize that 44 is our minimum number, not 77, right? So meaning 44 will now become our minimum number, right? So going back to the source code, it means that in this particular variable, min will now get the value of index in, right? However, uh, students, I need you to understand that actually the minimum number here is not going to be changed or affected. Why? Because this variable is declared outside this inner loop, right? So we are only, in other words, this particular code is temporarily saying, right? Temporarily saying that your minimum number is now 44, not 77. But actually, it does not mean that the original value of minimum will be changed, right? So it simply means it's taking temporary. It only takes temporary the value of n temporarily as our new minimum number. In other words, it simply means that oops, we now have